Hello everyone, myself Yadagiri, Assistant Professor, Department of EEE, MLR Institute of Technology, Hyderabad, and I'm also the faculty of BEE. In the last session, we have discussed about the how resonance condition will occur in the RLC series circuit, and after that, we have determined the resonant frequency value and also the quality factor of the signal system or RLC series circuit, and based on that, we also determined the bandwidth of the RLC series circuits. So these many things we have discussed in the last session. So in this session, we are going to discuss about the problem based on the resonance in RLC series circuit. So now let's begin the session. So in that very first problem, a series RLC circuit with the resistance of 10 ohms and inductance of the 1 millihenry and as well as the capacitance of the 1000 picofarad. So which are connected in series to the each and every one, and which will connect to the an alternating source of the 20 volts. And based on this one, we need to find the resonant frequency value and also the quality factor of the network, and as well as quality factor under the resonance condition, and as well as determine the half power frequency. That means to say, so F1 and as well as F2 values we need to find. So then we need to go through the given data. Then based on that, we need to substitute the values in the required formula. We will get the required parameters, required values. So for that solution, we need to take. For that, quickly take that given data. So that is resistance of the network is given as 10 ohms. Then inductance offered by the network should be, it is a 1 millihenry. That means 1 into 10 power 3, 10 power minus 3 henry only. And the capacitance should be equal to C equal to 1000 picofarad, which means 1000 into 10 power minus 12 farad. Pico means it's a minus 12 farad. So in this one, the very first question asked for determining the, and also given some more value, that is 20. I think 20 is a what value? It is a applied voltage. Under the resonance condition, the voltage appear across the circuit should be equal to 20 volts. So that is the sinusoidal voltage or AC voltage given as 20 volts. So based on that very first question, that is FR asked. FR means resonant frequency, or also sometimes we can say F0 also, that is 1 by 2 pi then root LC. This is the formula of the FR. So the last session we have derived that. So all our known values we need to substitute directly, then we will get the resonant frequency value. It is a 2 pi into the L value should be 1 into 10 power minus 3. Then C value should be 1000 into 10 power minus 12. So based on this one, the FR should be equal to, it is a 1.5. So we have done, I have already calculated this value. So based on that, it is a 159,155 cycles per second. 1 cycle per second is also called as the 1 hertz. So that's why the FR or F0 should be equal to 159,155 hertz. The next one is second one, or second question asked, that is a B asked. Find the quality factor of the system. Find quality factor of the RLC series circuit under resonance condition. So because they asked the quality factor under resonance condition only, so we have just now derived. The last session we have derived, that is a quality factor equal to the, it is a 1 by R, that is a root over LC. So here 1 by R means 1 by 110, 1 by 10 into, so square root of, so L means it is a 1 into 10 power minus 3, then divide by, so here 1000 into 10 power minus 12, because it's a kilo picofarad. Sorry, it's a peak of 1000 picofarad. To say 1 kilo picofarad, that means 10 power minus 12 farad it is. Then the quality factor should be, then the QF equal to, the Q factor, quality factor equal to. So based on the simplification of the above terms, then we will get the quality factor should be, it is 100. So it is simply 100. So there is no unit for this one. So because both units are going to get cancelled, for that reason there is no units for the quality factor or the Q factor of the RLC series circuit regard to the given data should be equal to, so 100. This is the answer about this previous question. So the question number 3, they have asked like what we want to find to determine the half power frequencies. That means to say half power frequency means it is a upper and lower cutoff frequencies. So that we need to find the upper and lower cutoff frequencies. So that is the question number 3. The question number 3, the F1 equal to the FR minus, sorry, it is a R upon 4 pi L, R upon 4 pi L. So we need to substitute these values. It is a 1, yeah, 159,155. Just now we have derived that, I mean we have determined that it's a 159,155. So 159,155 minus resistance is the 10, then divide by the 4 pi into 1 into 10 power minus 3. So based on this one, F1 should be equal to 1583. After calculation of these things, we will get that to 158359 cycles per second. Then F1 equal to simply 158359 hertz. So this is the upper cutoff frequency of the bandwidth. Also we can say this one is a half power frequency, that is a lower cutoff frequency, sorry. Then I need to find the F2 value. F2 equal to again FR plus what is that, R upon 4 pi L. Then substitute these values in the formula. Then we will get it is a 159155 plus 10 divided by the 4 times of pi into 1 into 10 power minus 3. Then after simplification of these two terms, then we will get that as a 159155. So this one, the whole term we will get it as the 796. After simplification of this one, we will get the 796. The overall low upper cutoff frequency should be, it is a 159951. So it is a cycle per second. CPS means cycle per second. Therefore F2 equal to finally 15995 hertz only. 1 cycle per second is same as the 1 hertz. So this is the half power frequencies. So F1 and also the F2 we got. So based on this one, we also find the bandwidth of the signal or bandwidth of the frequency. So this is the end of the first problem. So asked about the what one? Asked about the first of all resonant frequency value. Then we have done that is. Then after that quality factor under resonance condition also asked. Then we have determined that quality factor should be equal to. So the Q factor QF equal to, we got it as 100 only. So because there is no units for this one, because it's also called as a magnification factor of the voltage. So both voltages gets cancelled. Finally, there is no units of the quality factor. So it was also discussed in just now, in the session just now. Then also after that, we need to find the half power frequency. That means F1 and F2 values. So then this is the end of the whole problem. Then next we need to discuss about the one more problem based on the resonance condition only. So there is a problem number 2. A coil of resistance 40 ohms and also the inductance of the coil should be the 0.75 Henry. So which used to connect the in series to the whole network. So which under the resonance condition, the frequency offered, that is resonance frequency offered by the network should be 55 cycles per second. That means 55 hertz. If the supply frequency of the system, that is a 250, 50 cycle per second. So based on this one, need to find the line current of the network and also the power factor and as well as the voltage across the each coil and voltage across the whole coil, we can simply say. So this was asked. Whole problem given the resistance value and the inductance value, and after that we need to find the using this data need to find the line current value, line voltage value, and as well as the power factor of the network. So these many things we need to find. So for this need to quickly go through the given data. So then we will take the given data of the network. So this is the given data. What I mentioned, it is a R equal to 40 ohms given. Then L value should be given as 0.75 Henry, and then frequency, that is a FR is mentioned as a 55 hertz. 55 cycle per second means 55 hertz. So then based on this one, also given some voltage and also the supply frequency. Voltage value should be as a 250. So will be the 250 volts. Then FR is a, sorry, it's a supply frequency means FS is a 50 hertz or 50 cycle per second. So for this determination of the what value, line current, then power factor and as well as the voltage across the coil. So for this very first question, first of all under resonance condition we need to find the voltage across the inductor and also the voltage across the capacitor. So before that under resonance condition, under the resonance condition, the net reactance will be equal to 0. That is XL minus XC equal to 0. So we know the XL value, that is a 2 pi FL, 2 pi FR into L, which means XL equal to 2 pi, keep as it is. FR value we have already got from the question, that is a 55, we need to substitute. Then L value as 0.75 Henry. After the simplification of these two terms, then reactance suffered by the network under resonance condition should be equal to 259.18 ohms we got. So XL and XCs are both equal. XL also the XCs are equal together under the resonance condition. That's why it is a 1.8 ohms. So this is the resonance condition of the XL and XC values. So based on this one, we need to find the capacitance of the network. So that is capacitance should be equal to, so C equal to, we know that XC equal to 1 by 2 pi FC, 1 by 2 pi FC. Then C equal to, so we want to say C equal to 1 by then 2 pi into XC into FR. After the simplification of these all terms, so we will get the capacitance of the network should be, so 11.165 into 10 power, so minus 6 farad. So after the simplification, we got this value as minus 6 farad value. So this is the capacitance of the network under the resonance condition. So but asked in the question, the line current, power factor and also voltage across each coil, if the supply frequency should be as 50 cycle per second or 50 hertz. So for this value, we need to find the line current to these many things. So for that, the very first question, at 250 volts as a V and F equal to 50 hertz. In this condition, we need to find the first question, that is the line current. IL equal to, it is a V by Z. IL equal to V by Z. So V given in the question as in terms of RMS, then need to find the Z value. So Z equal to impedance suffered by the network under the, so this voltage condition. So it is a square root of R square, then XL minus XC whole square. So based on the XL and XC values, based on the domination of inductor reactance and also the capacitor reactance, we will consider this term. So that was discussed in the RLC series circuit. So if it is a capacitor domination under the inductor, then we can consider as XC greater than XL, which means XC minus XL we can consider. So if you are able to if you are able to do the domination of the network as a XL, so which is on the capacitive reactant, that is XL minus XC we can consider. So based on the condition only, we would like to take this one. So for this, so need to find first of all XL value, then XL equal to, so it is a 2 pi FL, which means based on the substitution of these values, that is a 2 pi, then F is a 50 into 0.75. Then after simplification, we will get this as the 285.1 ohm we got. 285.1 ohm. Sorry, it is a, after simplification of this one, 235.62 ohms we got. Then similarly, XC equal to, it is a 1 by then 2 pi FC. So we have already determined C value. C value will not change, but XC will going, XC value going to change because of that will that is depends on the frequency. That's why XC value is going to change, but C value doesn't change. So that C should be same only. C value how much? 11.165 farad. That is 11.165 into 10 power minus 6 farad. So based on that, 1 by 2 pi into, so 11.165 into 10 power minus 6 farad, so into 50. So for this XC, we will get it as after simplification, because I got the answers like so 285.1 ohm. So in this case, XC dominate the XL, that's why XC is greater than the XL. So for this reason, the network impedance should be equal to the, it is a square root of R square plus, it is a XC minus XL whole square. So based on this one, after substituting these all the values, we will get that as a, it is a 10 square. I thought it is 10. Yeah, it is a, sorry, it's a 40 square plus square root of 285.1 minus 235.6 whole square. After the simplification, the z should be equal to the 63.63 ohms. Therefore, the first question, that is I value equal to the IL equal to the V by Z, means it is a 250 divided by the 63.63. 250 equal to the 63.63. Therefore, the line current should be equal to the 3.93 ampere we got. So this is the first question answer. This is the answer about the first question. Line current they have asked. Further, under the resistance condition, we have utilized it to get the capacitance of the network. Capacitor value of the parallel plates. So based on that one, we need to get the, this is the procedure we follow to get the IL value, line current value. Then after that, so second question asked as what they have asked. Second question is power factor. So very simple one. So the power factor is a cos pi equal to, it is a R by Z. R is a 40, then divide by 63.63. So then after simplification, power factor should be equal to cos phi equal to, so we got it as a 0.704 like that. So this is the power factor offered by the network. Then very last one, voltage across the coil they have asked. So based on the voltage and based on the current value and also the reactance value, we need to get the voltage across the, so each whole coil, that is VL equal to the I into XL. Also we need to find the VC value, that is I into XC. So if you are able to substitute this values in the these two formulas, so we will get the voltage across the inductor and as well as the voltage across the capacitor. So this is the end of the session. In the last session, this whole session we have discussed about the problems in resonance RLC series condition. In that, resonant frequency value. So that's FR value. Also we can say F naught value, then quality factor. In the very first question, we have discussed about the FR value, then quality factor, and as well as the power factor of the system. We have discussed it till now. And in the second problem, we have discussed about the under resonance condition, what do you mean by XL, and also the XC value, how much. So for the different frequency, for the supply frequency, what is the XL and what is the XC values also we have discussed it. And after that, the impedance offered by the network also we have discussed it, and also the line current value, and based on that voltage across the inductor and also the capacitor, and after that power factor of the whole network under this condition. So we have determined till now. So this is the end of the session. In this session, we have till now covered these many things. So thank you one and all for the session. So in the next session, we are going to discuss about the three-phase balanced AC circuits. So thank you and all. Thanks for watching the session.